Everyone. So we are going to cover these three topics: lambda, foreach, and functor. So these will be very much needed in the our concurrency chapter. So before we start the lambda, let's see that what are the multiple paradigms of the C++. So mainly we have four styles. So we can say first is the procedural, second is the object oriented, and third is the generic, which is the template oriented, and fourth is the functional style programming. And the lambdas are very much used in the functional style programming. So what's first is the, let's see what's procedural programming. The procedural programming, our emphasis on the how the writing the code actually, the how the thing work. So it's focused on procedural routine. We write functions, the procedures to operate on the data. So we have a clear sequence of steps to perform of the data. For example, if we want to add an array, so this function is an add array. It is accepting this span array, which is that array, and then we are writing that initial is total, and then we are getting element by element, and we are adding to the total, and then we return the total, right? So we have written the complete instructions, clear sequence of steps, that how the array is added, and that's what is the procedural programming. And in the main, we can use this. We have an array, and we can pass this array, and then we can get this stuff, right? So this is an example of the procedural programming. Object-oriented programming need no introduction. So it is around the objects and classes and the data and the functions. While procedure is mainly the focus is on the functions. In the classes, the data and the function is encapsulated in a single unit, right? So the functions operate on the data. And then we create the objects, and we know the inheritance, polymorphism, encapsulation, and abstractions are used. So that's the object-oriented programming style. Then we have the generic template programming, template-oriented programming, where we use the templates to write generic and reusable code. So here the emphasis is that we should not be writing code just for the data types. Like we are writing one class for the integer, other has some float members, or maybe function uses integer and other may be using some float member. So we should not be writing that. We should write a generic class, like we have a vector. So we can create a vector of integer, we can create a vector of object. So that's a generic class. Similarly, we can create our own functions also, that's generic. So the emphasis is on the generic programming. So it allows function and classes to operate with any data type. So data type is not relevant when you use the generic programming, and it doesn't sacrifice type safety, right? So you can still replace the type, and the compiler create a different version for that. And we have done these examples already. So this is an example of add array in case we want to convert this function to a generic programming. So we'll say template type name t becomes type name, and then span is of type t, and total is of type t, and so on. We're still writing all the sequence and steps that how the array is added, but this is now generic. It's not dependent on the type. And when we call in the main, so we have add array, and we can pass that I want integer version, and then I'm passing the a, and if I want double, then I'm passing the b, right? So in both the versions will work, and they will give us the answer. So that's the generic programming. Now we'll talk about the function style programming. In the function style programming, our emphasis is on what we need, not how, right? We specify what. So we want to add array. That's what we will say, only that add these arrays, and we'll not tell that initialize this, add element by element. That's not our job. That's the job of the library, right? So the library code handles how. So it encourages in a declarative style. So you just declare that I want this thing, and then we have some function in the library that does this task. And this task is easier to parallelize. The way it's written is easier to parallelize, which can improve performance on multi-core processors as well. Okay, this is an example for say here we have used here numeric library, and we're mainly using the standard accumulate, right? So we have an array here, and this is a constant expression, means that this will remain constant at the compile time, because we are going to pass this array to a library, and we don't want any modifications to be done by that library function, and that's actually the emphasis also of the functional style programming. It ensures mutability. Unless you say change it, can't be changed, and you can be sure also with the declaring it as a constant expression, right? So we have initial total is 0, and now we are saying standard accumulate, and here we have the standard begin, which is an iterator. So this will give us maybe the first element. Here we can say it just says that go from begin to end of this array, use the initial total this, and then accumulate. So accumulate is a function that will reduce it to a single number of all these numbers, right? And by default, it does addition, right? If you don't pass, we'll see that how the accumulate can be changed. So what accumulate does is, so if by default operation is addition, so it does the addition based on the initial value. So initial value is added to first number, starting from begin, right? So 0 plus 1 become 1, and then the result of this you can consider it as an accumulator. So accumulator is 0 initially, and then accumulator is added into 1, it becomes 1, and then accumulator is added into 2, it becomes 3, accumulator is added into this, it becomes 6, and 4, 10, and then 15, right? The accumulator is added. So that's what accumulate does is, so it applies this function on each element starting with this one, right? But we have not defined it that how this is done. So you say just accumulate, reduce it to a single number, use begin and this is the initial total, and we'll get the total. That's the functional style programming. Now we can pass functions as arguments to other functions, right? So like we have this accumulate function, and now we will pass another function in this accumulate function. So we can say this is a higher order function, and for that we'll use the lambda function, right? So let's now see what's the lambda function. So lambda functions are an anonymous function object. It has no name, and these are anonymous function defined where needed without a name. Right. So right now, for example, here also we say that we have defined a function add array at some other place. But if we really don't want that function is for one-time usage, it's not required that we should define it somewhere else. We can define it where it's right now needed. It's ideal for one-time tasks. It removes the need for separate function definition. So there is no need of separate. We can just define a temporary function like an R value, and that is an anonymous function. In fact, it's a pure R value, PR value. Lambda function object has a unique unnamed class. Lambda function has a class, and it's unnamed class, right? Unnamed means we are not naming. It's generated by the compiler, and since we don't know what compiler is going to generate for our lambda function, we just say auto, right? So we just say whenever we write, so just say auto class type. So typically lambdas are used to, if we want to send some code to algorithm, for example, here in accumulate, we want to pass some function, some code to the algorithm. This is the function actually you need to use to reduce it to a single number. So we want accumulate, but we want not the addition, but we want our function to be used to accumulate, right? Or for if there is an asynchronous function, then also we want, so you are a different thread now and use this function. So for that purpose also we use lambda functions. Okay, let's say that we want to reduce it to a single number but by multiplication. So we have here multiply. We defined a multiply function. So it takes the accumulator, which is initially it will be the init, and then it will reuse the same results. So it takes accumulator and another number, right? So this number will be changed from the iterator. So we pass the vector, and then this number will be first element, then second element, third element. This is the result of the previous, and it returns the multiplication of this. So obviously, if we want actual multiplication, accumulator needs to be set to 1. Otherwise, if we set to 0, then it will all be 0. So we need to set initial value as a 1. Not here, but in the accumulator, in this standard accumulator. So this function can also be written as like this one. So I'm just introducing that this is true for any general function, but in lambda we need to use this. So this function, for example, has a return type of integer, but there is no need to write the return type integer here. So we can write as a trailing return type. So we can write arrow and then integer. So this and this both are exactly same. There is no difference. So we can use this function or this function, right? But for lambda, if we want lambda function to return, so we use this one because left side return type is not possible. So we have multiply integer, same thing, accumulator into y, and then it returns integer, and then we have the return statement. We should not be writing void here because we still have the return type. It just says auto here. Okay, so passing multiply to this. Now what we'll do is we'll create a constant expression again. We initialize with the 1 and then we say standard accumulate, and we start again with the begin to end, and initial value is this 1 and then multiply, the multiply function that we define. So now we are passing that function in the accumulate, right? So this accumulator, it becomes a higher order function that receives a function, and we have already written this function, and then we can just get the total. Okay, so this is the 120. Now, we can have a generic function as well. Like we can create this multiply with the template type name, so no need to write the type. And if you want to pass this generic function to this accumulate, we can say multiply with integer, right? So because this is an integer, if it's a double, so we can write multiply with double. So any function can be passed to the accumulate. It really doesn't matter. So you can define the way you want to accumulate to a single number. You can pass the objects also. It just says that I am going to start from here, will go up to here, will use this as initial value and apply your function on in sequence by picking one element, all the elements, and starting with this one. So that's what it does. How you define this function, the accumulate is not present. If you don't define, then it reduces it to by addition, right? So we get a 120 here. Now, instead of defining this multiply, because this multiplies is also an overhead. So we are writing a function definition and we need it only for one time because everything is taken care by accumulate, and we don't need that multiplication, addition, or our reduction function again, right? So in that case, we can use the lambda function. So we are passing now the lambda function instead of defining. So we don't have any multiply now. So we are saying begin at A, end at A, this is the initial value, and that's the lambda function. So what essentially lambda function is, it starts with square brackets, which is the, you can say, is the introducer, and we can call it as a capture list. We'll see this later. So this is introducer that starts the lambda function, also called capture list, and then the parameter that we passed. So we're still saying x and y. You can say accumulator y. So we have integer accumulator, integer y, and then return accumulator into y. So it returns this. So that's what we need to do. We don't need to name this function. We can say just comma and including semicolon, and this is passed in the parenthesis. So all the codes are written separated by comma. If you have multiple instructions, that's perfectly okay. So you can write as many instructions as you want. You can just split this into this line. So this complete is an accumulate that will replace it. So what we have done essentially is that we have passed the lambda function in this format, and then we get the total. Okay, so maybe we may have a more cleaner version. So you will see in number of code, I mean, in the professional libraries, the code may be written like this one, that everything is passed. They don't define as a separate, but you can do like this one, maybe a more cleaner and not many indentations. So we have auto F1. So this is the lambda function. So we have saved this function into F1. So F1 is our lambda function. In fact, it's a closure, we call it a copy of closure. So F1 is a closure, and closure is similar to an object. Like we have a lambda expression, which is like a class, and then we have the closure like an object. So this will actually exist in the runtime. So F1 is a closure, and that we pass this closure to accumulate. So we have accumulate, it starts with begin A, it ends at A, and end of A, it starts with initial value, and F1 is passed. That F1 needs to be used, and that's the lambda function, right? So, and then we'll get the total. So maybe you may prefer to use this one, or you can directly, in no need to write y to create unnecessarily F, just pass it here, right? So you can do any approach. You can also pass objects to standard accumulate, like we have a employee class, and let's say that we have a monthly pay for the employees. And what we're going to do is, now we created the three employees, and we created set their pays and created a vector of the employees, and then we pass begin employees, end employees, start with zero, and take the accumulator, take the employee, and add the employee pay into the accumulator, and then add these totals. So you'll get this total. Okay, so now we'll formally introduce the lambda function. So lambda function is this format. So this is called the capture list or the lambda introducer. So we'll talk about this capture list soon. So this is called the capture list, where we want to capture the local variables, and this is the parameter list that we have just now used, where we pass the accumulator and the y, or x and y. So that's the accumulator, and that's the code. Actually, that's the main part. So this is the parameter list, parenthesis is the parameter list, square bracket capture list or lambda introducer, and the parenthesis and the braces is the main part. So will write whatever we want to write. For example, in the previous we wrote return accumulator into y. So, and we can also save in as a closure, copy of closure. F1 is contains this one. So F1 is the copy of the closure, and rest all is same. Up to us. How do we want to define? So let's say that we have here main, and n is a local variable, and we have f1 as a lambda expression, and then we can call f1 with the parenthesis, right? So this is very simple way of calling. Otherwise, it's used to pass to the other function, but you can use also like this one. So f1 is this, and then you can put the parenthesis, and it will execute this function. And whatever is written here, so it will say hello. So now we have a callable function. Let's say that we want to pass this function to another function, not standard accumulate, but we want our callable function. So you can say call function, and it accepts this function, and this function's type is a new type. So we don't know what type it is. So it will be passed at the time of calling, right? And that type is auto from that. So it accepts some type, and then we say standard cout calling function, and then this function is accepted, and then we put the parentheses here. So this function will be called and say function executed. And here we have the call function, and in that we are directly passing this hello lambda, and that will work. Okay, so callable function here. So you can also pass the lambda function. You can say it's stored in the f1, and then I'm passing this f1. So this is going to work. You can also have the trailing return type. So you can say that this lambda function, it doesn't print, but it returns hello. So you can say it returns standard string, right? So here, because this auto is used for the lambda's return type, which is generated by the class. So we don't have the return type, so that's why we use here the trailing return type. So here's standard return string. Okay, so and then we can say standard cout is here in the main. So we define this f2, and then we put the parentheses, and then we get the value. Okay, so now let's say that we lambda function wants to access a local variable. So we have n as a local variable, and we have f1, the same code, and then we are accessing this. Okay, so in this code, it accesses hello n. So it's n the value. So you can see that it's very simple, that we have a lambda expression here. It is f1, and then n is being passed here, but the compiler doesn't allow that. It says n cannot be implicitly captured in a lambda, and with no capture default specified. Like, so we have not specified, you have not defined the capture, and implicitly you can't capture, it's not captured, right? So this is the capture list. So if you want even the local variables to be passed to, so immutability is core at the lambda function. So if you are passing, if you can't directly access any of the variable, although it's in the same scope, it can't access directly. So you need to explicitly say that you need to access this lambda function is allowed to access this variable, and that's what this square bracket is for. So we can say that, let's say that we have two numbers n and m, and we say f1 and m. So we are passing it here. We're not passing any values here. So if we want to pass any external value, that's the parameter list. So if you want some local variable to access whatever their values are, so we'll just say n and m. So this lambda function can access this n and m, right? So if you say hello n and m, now there is no error because both are one. It will say hello 1 1. trying to modify the captured variables. So let's say you passed, but in the lambda function you modified this value. Again, this is not allowed. Remember, immutability is at the core of the lambdas, or in the functional programming. So you can be sure that if you say that this thing, so it can't modify that. So this lambda function modifies this, so it's not. It'll say cannot assign to a variable captured by copy. So it's to a non-mutable lambda. This is lambda is a non-mutable. So it's only can read these values. It can't modify these values, right? So you're going to get this error. But if you want a mutable, so you need to explicitly say that's solution one. You say nm this is mutable. So any variable you passed it captures can be modified. So you can plus this and you can have these updated values. And in fact, you will get the values of n and you will see the updated value. So that's one way that you can pass this as a mutable. You can declare the lambda is mutable, so it can modify. But the second is you can pass that value as a reference. So then there is no need to say that it's immutable, because when you pass by reference, your intention is that the value can be changed. You know that this value will be changed. It not can be, but will be changed. That's why you're passing this reference. Okay. Okay. So this is plus plus n, and then we can see this is hello to one. You can also pass the parameter. We have already done this. So we have n and m. So in this case, when we pass the parameters are passed in the function call. So we have m plus plus. We say hello m. So earlier it was no parameters because our parameter list was empty. So but now we have two parameters. So it means that when we call this lambda or closure, so we need to pass the parameters also. You can have a constant parameters also similar, like this parameter is constant, so you can be sure that this parameter can't be changed by the lambda function. So if you do this, then you'll get this error. Custom version of accumulate. So you can write your own accumulate. So this is a custom version. So we have a multiply function, and then this is the accumulate where it's iterator. It takes first and last initial value and a function. What it does is it goes from first to last, increase by first, and then this is the function that it receives. It applies this function on the initial value and the first value, because first is getting changed. It applies this and result is stored in the init, and then this function is applied in sequence in the loop, and then it returns the initial value. So this is how the lambda works. It has no function, no method here. So you pass the function that you want addition. If you don't pass, then by default is addition. And if you pass the multiplication or objects, want to accumulate to a single number from multiple objects, it does everything, right? So that's the accumulate. And this is how you can use the accumulate. Instead of standard accumulate, you can use your own accumulate, and then you'll see the result is still the same. Only thing is our accumulate doesn't have the default operation, which the addition that we can operate it. Next is the for each loop. For each loop, it accepts a function to execute over each of the container element, right? So we have elements in a container, and we want a function to be applied over each of the container element defined in the include algorithm, right? So this is, and this in this case also we will use the lambda function. So let's say that we have a vector of integers and there are three elements here. So we're saying for each, right? For each means for each of these elements, starting from begin to end, apply this lambda function, right? And what it does is in the lambda function, it gets this element. So you're getting this element and say hello element, right? So we'll get hello 1, 2, 3. Right? So for each loop, we have a function here, and this is the lambda function, and lambda function accepts one element, and this element is this one. So this applies essentially this function on each of these elements. It doesn't reduce to a single number. So it just applies that function on all of the elements. Not all, essentially, where you say that it should start from here and end from here. And similarly, you can also make it more cleaner. So you can say this is our lambda function. It accepts this function and does print the hello that element. And now in the foreach, you can say foreach, start from it, end this, and apply this F1. Right? So maybe you may want to use this approach. Next is the functor. Functor is a function object. So now it's an object that acts as a function. The object can be called as a function. Like we have an object which is the my class. So we have an object. Now this what do you mean by function? So when we say a function, when we have the parentheses, so it means that if we can put the parentheses with this object also. That's what it does is. So in the object we are adding the parentheses 2 and 3. It means that this object is accepting. It's not a constructor call, it's a function. So this object is acting as a function then 2 3, because for constructor we need my class. So we are using this object 2 3, and there will be some function defined that what this when we call this object as a function, what we want addition, we want multiplication. That's what we need to define it somewhere. We need to overload this function call operator, which is the operator parentheses. So this is the operator. Like we have operator plus, and we overload the operator plus, and then we pass the parameters. Now we have the operator parentheses, and then we pass the arguments also. So we may see the double parentheses here. So one is the which operator is being overloaded, and one to pass the values, for example, to accept these values. So here we have a my class and we use the operator, and this is blank. So it means that there is no parameter here passed. So we have overloaded this operator and it says return 0. It means that if you create the object of my class and treat that as a function, that function will return 0. So we have an object and we'll say object, and we added the parentheses and say what's the value of this object as a parenthesis. Cout says it's 0 because we say it's 0, right? So in case we want two parameter constructor, so we say operator this, and then we have, you will get two values and two parameters, and then you need to add these two values and return it, right? So here we'll say we created an object of my class integer, and then say object 2 3. The moment we pass 2 3, this is invoked, right? So this becomes 5, and then we'll get the value 5. So what essentially we're doing is we have the object, and we are treating this object as a function. That's the functor object, function object. We may write like this, that we have an add function, then we call object dot add, but that's an unnecessary. So we are creating the object as a function. Okay, so we can have multiple operator overloading here. So we have operator this with 2 parameters, we have this with 3 parameters, and we have this with no parameter. With no parameter it returns 0, with 2 parameter it returns addition of 2, with 3 parameter it returns addition of 3. And we can create and treat functor like this. We created an object and then we say no parameter it is 0. When we pass 2 parameter it runs a 5. When we pass 3 parameter it runs of this. And you can define as many, you can overload with number of implementations. So that's all with this, and next lesson will be on the concurrency. Thank you.